Hi, so welcome to the another class of Internet of Things. So we have been studying about various IoT convergence protocols here. So we have studied till far the broker-based protocols, which includes your we have studies the broker-based, that is protocols like your COP, your MQTT. So in this class, we will study another broker-based protocols, which is your AMQP, which is your Advanced Messaging Queuing Protocol. AMQP refers to Advanced Messaging Queuing Protocol. So this protocol AMQP here is an open standard application layer protocol which is mainly regarded as or it provides the interconnectivity between the various clients and the middleware. So if I have to define middleware, so it can be regarded as a software which either connects all of the software components or the various enterprise components. That means if you have two different components of a system, so this middleware will connect these two layers here. So we can say that AMQP is here focused on providing the interoperability. That means this is the main feature for your AMQP. It is the advanced messaging queuing protocol. That means it will accept the messages from the clients, then forward it to a certain queue and then to the consumer who requires those messages. So this is also in convergence protocol, which is used for your Internet of Things, which comprises of constrained devices. We refer that network as a constrained network as it is a low powered and low throughput requirement network. So we required certain kind of lower version protocols. That means light weighted protocols. So the various features of this protocol The various features of these protocols include, first of all, to provide the interoperability between two layers here. After that, it provides the message orientation, that how the message will be oriented, how we have to structure it. After that, it performs your the message queuing, that converting all the messages into a particular queue of messages. After that, it performs the routing of that or routing of those messages. Now, this routing here is either point to point or subscriber, a publisher, from publisher to this subscriber. So we have interoperability, we have the message orientation, the message queuing, the routing, and after that it provides, or the other important feature includes reliability and scalability of this protocol. We have reliability and scalability of this protocol here. So these are the certain features of your AMQP protocol, Advanced Messaging Queuing Protocol. Now next is that what are the different layers? So basically this is divided into two layers. So the first layer which I have here for you, AMQP, it is split into two layers here. The first one is your functional layer, and the next one is the second one is your transport layer. So if I talk here about your functional layer, so it contains certain messages in the absence of certain applications. So I will just describe it what are the various functions which are performed by this layer. So this functional layer here is concerned with certain functions like message routing. When from this layer to this layer, this is the main function of this layer, that it will be performing the message routing, the message exchanges, and the queuing operation, which is the most basic operation of this protocol. Now, if we talk about the transport layer, so transport layer is responsible for the transportation of these messages from the application to the server. After that, it performs the channel multiplexing, then the content encoding, and the data representation. So these are the functions of these two layers in which this protocol is split up. So according to this, we can say that the requirements here for this protocol is that it should be able to provide the interoperability. Then it should be able to multiplex several channels here on one transportation channel, and about content encoding, it should be able to convert the data into binary encoding and then transport it. So this is just the layered splitting of this architecture. Now next we will see that how this complete transportation takes place with the help of this architecture of this AMQP protocol. So next we have the architecture. So for architecture, I have in this architecture for AMQP, first of all, a server. After that, I have virtual host. Then the next components I have next one as an exchange. Then I have these message queues. Now, above that, I have here client publisher, or we can say a publisher application, and here I have the consumer application or the consumer client here. So this is the architecture here for your AMQP protocol. So I have a server. After my server, I have a virtual host, then exchange, and then the messages, the queues of the messages, and then the publisher application and the consumer application. Now, first of all, I have my server here. Now, server here is a process which is responsible for accepting the connections from the clients, because server is here maintaining the complete system, so it will be acknowledging that what kind of or what are the various requests which are made here by the client. So it is here responsible for accepting the client connections. Now, after accepting the client connections, it is responsible for routing the messages to the appropriate consumer here. So server is on the topmost of this architecture. After that, we have the uh, above lying units which will be doing all these functionalities. So this is just accepting here the various connections and implementing the AMQP messages and then queuing, or we can say that forwarding those messages. Now, after server, I have my virtual host. So, virtual host is basically a data partition with your server, acting as a data partition system here with your server. Now, then I have my publisher application and my consumer application. So, this publisher application is basically a client that publishes the messages to the server, or we can say that publish a message here to the exchange. It is responsible for generating or publishing that message, and that message is forwarded to this exchange here. Now, the next component here is the consumer application. So, consumer is basically a client who receives the messages from the message queues here, or we can say that it receives the messages from the exchange. So, this is forwarding, and according to the desired, what it has request, the consumer client, it will get that message from this message queues via this exchange here. So we have server accepting the client connections, managing the AMQP messages, routing and forwarding with the help of these sub units here. Then I have the virtual host which works in collaboration with server as a data partition. Then I have these two, publisher application and the consumer application here. After that, I have exchange and the message queue. Now, first of all, I'll talk here about the message queue. Now, queue basically refers to a set of certain messages here. So, a message queue is here responsible for storing the messages in a memory or in a disk, and it will be storing those messages here in an appropriate manner, or we can say that in a pre-directed manner here. That's what it makes a queue, because when it will have to forward, it will be forwarding those messages in that pre-directed manner here. So message queue is storing number of messages here in a redirected pattern here, and then forwarding these messages to the required consumer applications. As we can see that this is the message queue, so this is forwarding here these messages to the consumers here. Now, Messages basically stores, a message queue basically store these messages and distribute those messages. So this is basically a message storing and distribution entity. Now this message queue portion here has certain properties. So first of all, it has your shared, store and forward. So share, store and forward queue refers to that it receives a number of messages, it stores them and then forwards between the different consumers here. This is the most simple and the basic property of your message queue. After that, the next property is that a private reply queue. Second is your a private reply queue. Now, this private reply queue basically holds the messages, which is the basic functionality of your message queue. It will be holding the messages here. It means when you will implement a private reply queue, it will have those messages, but it will be forwarding those messages only to a single consumer. Those messages are then forwarded only to your single consumer here. So first one was your shared and shared store and forward queue. Second one is your private reply queue. The last one is your private subscription queue. Private subscription queue. Now, this private subscription queue here will be receiving the messages from various sources, but it will be forwarding those messages here only to the single consumer here. So that was just the previous one, receiving from one, sending to one, but it will be here receiving or storing the messages from a number of subscription sources, but forwarding those messages only to a single consumer here. Now, after the messages queue, the one component which is left here is your exchange. Now, as the term exchange indicates that it will be exchanging the information between the various entities here. So, exchange, if exchange is receiving the information here or the messages from your subscriber application, so exchange is basically not storing those messages. The storage is here done by only your message queues. So, it is receiving the messages and forwarding those messages to the message queues in a particular manner, in the order which they are received or in order in which they are to be forwarded. It will be forwarding those messages to the messaging queue. So that means you have the producer or your publisher application messages. These messages are forwarded to, or these messages are to be forwarded to this message queues, but you have the exchange here. So it will match and route. So your exchanges are basically matching and routing engines. It never stores any kind of messages. It just matches that in which queue it has to forward this message. It will match according to that order and then forward it to the message queue here. So that's why it's referred here as advanced messaging queuing protocol, because the main focus is here is in transferring those messages in a queue, because after that the message has to be transmitted here to the consumer application in a right manner. So this is the whole cycle for this protocol here, starting from the publisher application. Then when you transmitting a message, the server will be accepting your connection. Only then you will be able to forward the data here over this network with the help of a protocol. Now, Exchange will be receiving that and then matching and routing to messages queue. Now, queue will be receiving those messages and then ultimately forwarding it to the consumer application here. So this is how this AMQP protocol is implemented and used here for your Internet of Things. So this is basically a converged protocol used for constrained environment of your IoT here. So if you talk here about the frame of this AMQP, so each frame here can consist here of an header. So basically the structure is like this, like a typical frame. So it will have a different number of fields here, which starts here from type, what type it is, then channel, then size, then the payload, and frame end here. AMQP frame. So in this class, we just have studied here about one of the another IoT protocol, which was your AMQP. So this is all here for today's class. We will study more about IoT in our upcoming sessions. Thank you so much.